All right, we're live. Hello, everyone. This is Greg Johnson. I'm the CEO and co-founder of AquaPor, and I'm with my co-founder and the vice president of market development, Kevin Kunz.
Happy to be here.
As am I. All right, so this is a kind of a trial run. We are going to possibly start doing a recurring mini podcast, and I think it could be valuable for us and for anyone that's interested in this to bring on guests that bring new perspectives and just new information and wisdom pertaining to water and the environment and construction and things like that. But for our first episode, Kevin and I thought it would be a good idea to do a quick Q&A session, and we are going to answer the questions that we are most commonly getting through Facebook, through the website, and through our Start Engine campaign page. So what do you think, Kevin? You think we can handle it?
Let's go for it. Absolutely.
Okay. Now, I've put these together in kind of a hodgepodge format, but I think we just go through them in general. So for anyone that's not following us and you're just now seeing this and you're like, well, it looks neat or cool what AquaPor is doing, but tell me more. What we are a material technology and engineering solutions company that is addressing stormwater runoff and urban flooding. And we're doing that first and foremost through a patented pavement-like material that lets water flow through it while also filtering out pollutants. And so it all starts with this material. So the first question based on that, I think, Kevin, everyone for the most part, and rightly so, they lump us into the category of permeable pavement. And they say, well, isn't the material going to clog? How would you answer that?
Yeah, when we first started this venture, we realized that there was a market need in permeable pavement based on the size of the pore size. Conventional permeable pavements rely on large void space for infiltration, and we saw the opportunity in the pore size. If we could tighten up that pore size so much so that you would prevent clogging, if that was possible, that was our mission early.
Awesome. So one comment we got from, I think his name was Adam Al-Jamali. And I don't blame him, because he sees something new like this and we make this claim and he said, well, it's going to be clogged in a week. Well, actually, it's not going to be. We did a 6-month simulation where we took very fine silica powder, Sinkholes 106. And this is a synthetic stormwater constituent. The state of Washington, well, actually, nationally, they use this constituent in the stormwater industry to test materials to see if they have treatment capabilities. So, Kevin, you spearheaded these tests, 6-month simulation. Tell us about that. Like, what happened? Did the material clog? How much, I guess, what was the rate of removal, if any?
Yeah, when we became aware of Sinkholes 106, we immediately realized that we wanted to take the scientific route in defining why this technology was different in permeable pavement. And so we had this machine that was called a peristaltic pump that would take tubes from either end of an influent and an effluent into a sample with the Sinkholes 106 in the water. And so that water would come through the peristaltic pump into the sample. We would collect what came out, and we were measuring particulates. So how much of the Sinkholes was coming out of the bottom of the technology. And we had certain parameters that we wanted to meet. And, we ran this test independently, but officially, and we were very happy with our results. We greatly exceeded the expectations that are set as standards well known in the industry.
That's awesome. And that's why we're at this point right now. We kind of know what we have from a technology standpoint, and we're like, it's time to launch this baby.
Yeah, we're ready to go for sure.
We're ready to go. Another question, this is good, came up a couple times. How long does this material hold up in the presence of salts and even acids and de-icers? Kevin, go ahead and take that one as well.
Yeah, you know, again, early on in developing this technology, we focused on being, we called it chemically inert. So we wanted to, you know, be not immune, but really aware of what happens to traditional asphalt and concrete applications when those de-icers or salts or other toxins are present. And so, you know, we like to call ourselves a chemical rock at this point. It's permeable, and we're proud to be chemically inert.
Yes. And it's a key thing when you're going to have a material that's going to potentially be in the street or in a parking lot application or even in sidewalks. So the way our technology, the manufacturing process, I should say, of our material and the technology is such that we use an approach that, like Kevin said, it makes it a chemical rock. And what goes off and what happens during the actual process makes it completely inert to salts, de-icers, toxins, things that are inherent kind of in the built environment. One other question, and this kind of leads into that, how does oil impact the material? So I can speak to this. Obviously, oil is a hydrocarbon. Hydrocarbons actually, when they get into the ground, they become biodegradable. So they get eaten up by bacteria and things naturally in the ground. So the material is not impacted at all by oil. Now, it may take a little bit longer for that material to infiltrate through the product, and it just depends on the viscosity of oil. So when it's hotter, oil is more viscous. When it's colder, it's not. So yes, it could affect the infiltration rate, but it will still take on oil. It'll get into the ground, and hydrocarbons naturally get eaten up. So other stressors, pollutants, and toxins, I think we kind of covered that. What about paint? Okay, so if someone is on the street and they dump a bunch of buckets of paint, yes, it is going to clog the material.
Yeah.
And then that person should probably be fined for polluting the environment. But either way, the beauty of having a precast material is it can easily be dug up and replaced. So yes, paint will clog it, but that can be dealt with.
There was another question that was mudslides, and yeah, there are certain events that will affect our technology, but like you said, Greg, we like the idea of being in the curb line. You're not having to replace the entire roadway again. You can strategically replace as needed.
Yes, great point. Sinkholes. People seem to be very concerned with sinkholes, and probably rightly so, because that's a huge issue, like in Florida. And I think actually, Kevin, you were on this last year. You were following this quite a bit, where they have limestone soils, basically, that have been, the groundwater has been discharged at such a rate without being replenished that is actually causing sinkholes in Florida. But there seems to be this conception that if you direct all this water into one place, like through our material, it'll cause sinkholes. How can you kind of answer that or talk through that?
Yeah, some of those areas, and I know a lot of the aquifers across the country, we've been depleting them at a rate that's far greater than they can be replenished. And so when soil dries out, it becomes weaker, and then you have these sinkholes. For us, the issue of getting a lot of water to one area would be, hey, may it affect the underneath the roadway? And I've gotten that question a few times as well, Greg. And to address that, again, for us, this is going to be an engineered design. And so we want to pull water down and away, not underneath streets, to clarify. And so the purpose of this engineered design is to replenish groundwater supply and move it back into the groundwater table.
Yeah, that's a great point. So, and this is for everyone that's kind of following us, and you've seen probably the concept rendering of the material on the side of the street. That is going to be completely engineered. So let's just be clear about that. To your point, Kevin, is we are working right now with professional civil engineers and stormwater engineers that are at the top of their field. So it's not like just Kevin and I coming up with some idea. It's like we have real engineers that are working with us to design these street side public right-of-way designs. And so we're very confident in that. And that's part of the whole AquaPore solution, is the engineering around the material. So really good point there. Another question that commonly comes up, rightly so, is what about freeze thaw and the material freezing and cracking in like a Michigan winter, for example? You can take this if you want, and then I'll add to it.
Yeah, a lot of what we define, especially in our patents, is based on an organization called the American Society for Testing and Materials. And these set parameters, for example, for pavers or roadway applications. They want compressive strength above 8,000 pounds per square inch, and your ability to pass rapid freeze thaw cycle over a 28-day period. We exceed those expectations with this material. And so, the moment, say, snowfall becomes a liquid and hits our material, capillary action is going to drag that water straight down into the material. So you shouldn't have buildup of standing water that freezes and it eventually expands. We want to displace that water and carry it down as quick as we can.
Yep, exactly. The other thing is to keep in mind, I think initially as we go to market, our testing grounds will be here in Spokane, Washington, in terms of freeze thaw. And we're focused right now on coastal cities and certain areas that don't get a lot of freeze thaw scenarios anyway. So that's not to say we're not going to address the whole world with this technology if we can, but we are going to do our initial testing, get through a couple winters in Spokane, and I think we'll have a much better feel for this. But early lab testing indications show that the material does not crack through multiple freeze thaw cycles. So we're pretty confident about that. Kevin, hasn't this been done before? I mean, someone told me the other day that permeable pavement has been around for a long time. Are we infringing on patents? And I say that tongue in cheek, and I don't mean to sound like that, but yeah, that's a legitimate question. Like, this has been around for a while. You guys aren't doing anything new.
I'd love to address that. Back when, we were initially focused on developing this material, I met with many landscape architects and civil engineers. I wanted the industry to help us define what a true permeable pavement would look like. And really the consensus I got when we first talked to the market was, hey, permeable pavement is great in theory, but in practice, in 5 years, you're going to end up ripping it up. So I can't convince a client, a developer, a city to trust this stuff long term. We went into this, developing this technology with that in mind. And so to those folks, we know that this is an uphill battle fighting a stigma for permeable pavement. But Greg, I would argue that we're not even permeable pavement. We're a resilient solution and an engineered design on the side of streets. So it's kind of a different category altogether.
I agree. And that's just something we'll deal with. I mean, I think we'll get lumped into that category until we get these projects in the ground with real, professional feasibility studies around them, which we cannot wait to do. That's why we're out raising this money right now. it's super exciting because I think what people are going to realize is, well, it's like a concrete-like material, but it's completely different, completely novel. It's a chemical rock, like you said, that can be made permeable. But the beauty about it is it has the filtering characteristics of a ceramic filter, but it can be placed in cityscapes. And what goes around it, the engineered design around it, I think can open up just worlds of new designs, new approaches for urban stormwater management. And that's ultimately what we're trying to achieve here.
Yeah, we did do this unconventionally as a startup, being in that we were in research and development for a longer period than you would maybe normally see. Not for all, but for some. And we really embraced that. You know, we kept our budget low. We focused on the science and the technology. We focused on our application, how this product would look in the marketplace. And we also focused on supply chain, which, Greg, you can allude to that. That's probably the most important thing. You know, I can make a sample in my basement, but can I provide the whole world with a viable technology? And we approached that as well, you know, so pretty excited for what's to come.
Yeah, and it's a good point. You know, it's one thing to have, if you think you have a great technology, but you don't have anything unless you can make it and scale it up. And so the last 18 months or so, that's really what we've been focused on. Continue to develop the technology, get it to a point that, you know, we think it's ready to launch, but then get the scaffolding in place with value chain partners that can manufacture it, that can supply our raw materials at a cost that is not just competitive, but we think could be game changing, and get all these things lined up so that now when we're ready to press the button, we just launch and we go. So that's where we're at. I don't know. I mean, that's really the gist of the questions. Well, one more, I guess, is what happens when the material has gone past its useful life, which also brings up the question of how long does the material last? And I'll address that. We are working on a mixed design that puts it on par with ultra high strength concrete, which would give it 100-year lifespan or longevity. Now, if for some reason it gets rendered useless, if it does happen to clog, or if paint gets in it or something where suddenly the material does clog, how do you dispose of it? Can it be recycled? These are heady questions. The answer is yes. We are working on a full cradle-to-cradle approach for making the material, putting it in the ground, and then when it's time to rip it up and dispose of it, it can be recycled back into, cleaned and recycled back into construction aggregate to make more of the similar material. So long answer, but that's that. Anything else?
Just to add to that too, Greg, you know, you for years always talked about providing a toolkit, right? And so, you know, we want to take all these things into consideration to be an engineered design and a system for stormwater. And so that is definitely something that we will take serious as we approach those steps.
Awesome. Well, that's about it. Do you have any other parting words?
Please click in, like, and share. I know it's exhausting for those of you that are supporters of us and sharing the information. A share at this point is almost bigger than an investment, because the further we get out there on the internet, the more we have the opportunity to find our organic following. I also want to just thank everyone, all the support. I mean, Greg, I'm sure you've felt it too on your end. Friends and family, people we've never met that are just super excited for us to share this technology with the world. So we're very, I mean, Greg, I'm super grateful for all of you.
Yeah.
Thank you.
Me too. I'm going to echo that. We have, I think, 200 and some odd new investors into this round and this campaign. And I'm with you, man, from the bottom of my heart. Thank you so much just for being on this journey with us. We have huge, huge visions of what this is going to be in the future. and you people are helping us turn that into reality. So I'm the same way. Thank you very much. This is our first run at a podcast. It was a little dry. I feel like we're a little stuffy. We need like background music, or you know what? We'll get some guests on here, but the next one you and I do, it might have to be like cocktail hour or something.
Yeah, right. Well, yeah, we'll loosen it up.
But
there you go.
Anyway, thank you, everyone. Kevin, thank you, by the way, for everything you're doing too, man. Cheers, buddy.
Cheers, Greg. Appreciate it.
Yep. We'll see you all later.
Bye.